Here's my video tutorial for the notes on solving quadratic equations by completing the square. It's the first part of it, but it's chapter 9.3. And first, we need to notice two common characteristics of squaring binomials. That's x times d, where x is your input and d is a real number. So x plus d squared is going to be x plus d times x plus d. We can FOIL this out. The first is x squared. The outer is going to be d times x, or x times d, which becomes dx, because d is our number and x is our variable, plus d times x plus d squared. And this simplifies. I can combine dx plus dx to 2dx, and then I have d squared. So this equals x squared plus 2dx plus d squared. So if I expand out x plus d squared, I get x squared plus 2dx plus d squared. And for this form that we're used to, ax squared plus bx plus c, where in this case a is 1, for this to be a perfect square, there must be a real number d, where, so this d that we've been talking about, we have two common characteristics. One being that b is going to be equal to 2 times d. b is going to be the same as 2 times d. There's a number that that satisfies, or equivalently, d is going to be b divided by 2. There's also going to be a c that is d squared. Or equivalently, you can say d equals the square root of c, because c must be positive. C must be positive. That there's no plus or minus here. Now, examples. So we're going to talk about examples of completing the square for expressions. So we'll have two examples that we go over. The first one, if I'm trying to complete the expression as a perfect square, x squared plus 6x, so I can add whatever I want to this. I'm going to be adding a plus c. I know that I need to find a d that satisfies this. So d is going to be equal to b over 2. And I end up with d equal to 3. And then I can square that, because I know that c is going to be equal to d squared, which is 3 squared, which is 9. So I can replace c with 9. Now I have a perfect square right here. And that becomes x plus 3 squared. A second one, x squared minus 9x. How do I create this to be a complete perfect square? I'm going to be adding a c. And d, I'm going to have to find a d that is half of b, which would be negative 9 over 2. So c is going to be equal to d squared, which is negative 9 over 2 squared, which becomes positive 81 over 4. So I can replace 81 over 4, and this becomes a perfect square. And what is it the perfect square of? Well, I have d as 9 over 2. And you can FOIL that out to see that we get x squared minus 9x plus 81 over 4.